Good day everyone, Jan Ansel Rosel here, and for this presentation we will be discussing Unit 2 in Database Internals for the subject Advanced Organization of Databases. So, starting with the B3, what is B3? Now, B3 in the context of database management system is a self-balancing MY tree that can have a multiple child nodes. So, due to its balanced structure, it allows database to efficiently store, organize, and also for searching large amounts of data. So let's go into the properties of B3. So M represents the maximum number of child nodes that a node can point to. So for example, if we have a M is equal to 3, so 3 is the maximum child nodes that a node can point to. So number 2, the maximum number of keys that a node can contain is m minus 1. So for example, if we have a m is equal to 4 minus 1, so then we have a maximum of 3 keys in one node. So third one is a root node can either be a leaf node or an internal node. So root can have, for example, a 1 to 4 keys and 2 to 5 children if we have a m is equal to 5. So fourth one is the other internal nodes can have a m divided by 2 and m children, which helps prevent the tree from becoming too sparse. For example, we have m is equal to 4, so the internal node can have a 2 to 4 children. And finally, one of the most important properties is that all leaf nodes are located at the same depth. So makikita natin dito yung nasa pinakababa, yung kulay blue, no? So we have the 100 as the root node, yung green dito which is yung kanyang child node, that is the internal node, and then yung nasa pinakalas, lahat ng pinakalas is leaf node. And yung mga numbers sa loob ng node is which we call the keys. So, when a B3 is used as an index, each entry contains a key and data record reference. And also, B3s are stored in a sorted order, which enable faster data retrieval and reduces the need to scan every record. So for example, if yung database is hindi index, there's a possibility na titingnan nung database each record kung halimbawa maghahanap ka kung halimbawa sa searching. So because B3s are self-balancing and maintaining a low O-log-of-n operations, they are efficient for large datasets, throughput applications. They also make good use of storage by keeping multiple keys in each node. So, since mabilis yung B3s, efficient siya for large databases for insertion, deletion, and searching. So, however, B3s also have some limitations since they are designed primarily for large disk-based datasets. They may involve more disk access. They are also necessarily for every cases, no? Kailangan pa rin natin i-assess and depending on the applications and the datasets. And for small datasets, B3 may not provide as much benefits as simpler binary search tree. And as for the alternative of B3s, we have B plus trees, which are useful for range queries. Binary search trees are commonly used for in-memory data. LSM trees, which are optimized for heavy write operations. And then the prefix tree, which are useful for search such as autocomplete and hash indexes, which are very fast when we need an exact match. So now we move on to our next topic, concurrency control and lacking performance modeling. So concurrency control allows multiple transactions to run at the same time while maintaining data accuracy, consistency, and ACID properties, and also prevents conflicting operations on shared data, inconsistent database states, and lost or incorrect updates. So next is we have concurrency control protocol, which determines how DBMS manages and orders operations from multiple transactions. So for the first one is pessimistic. Pessimistic assumes conflicts are likely and prevents them. So for example, yung transaction 1 has a access on the data. So kailangan mo nang aantayin ni transaction 2 nung matapos yung transaction 1 before ma-access or magkaroon ng transaction 2. Sa optimistic naman, assumes conflicts are rare and handles them when they occur. So sa optimistic, pwedeng sabay yung transaction 1 and 2 to perform their operations, and then i-handle na lang yon when a conflict occur. So next we have execution schedule, which means it is the order in which the DBMS executes operation. So first we have the serial schedule. So serial schedules basically means that one transaction at a time lang. And then equivalent schedules, for example, we have to schedule two different procedures but produce the same results. The next one, we have serializable schedule. So meaning that kahit na mag-mix yung dalawang transaction, same pa rin yung result nila if we're going to separate the execution. Same pa rin yung kanilang result. So next one, we have lacking. So lack controls access to shared data and prevent conflicts between concurrent transactions. So we have two types of lack. So first is shared lack, which means allows multiple transactions to read the same data. And then next one is exclusive lack, which allows transaction to modify data and blocks other lacks. So exclusive lack is for write, and then S lack is for read. But sa XLAC, the others must wait. So next one is we have lack-based concurrency protocol. So first one is we have two-phase lacking or 2PL, which is a concurrency control method that uses lacks to control how transactions access shared data. So it has two phases. First one is yung growing phase niya. And during this phase, it only acquired needed lacks na kailangan niya to access a shared data, and kukuha lang siya if necessary. And once na mag-release na siya on those lacks, doon na magsisimula yung kanyang shrinking phase. And then from the shrinking phase, hindi na siya pwedeng mag-acquire ng new lacks. And then second one is we have the strong straight 2PL. And ang kinaibahan naman nito, it hold the lacks until commit. So hindi siya pwede mag-share ng other resources until mag-commit siya, saka lang ma-release yung mga locks. Next is we have timestamp-based concurrency protocol. First, basic timestamp ordering, which assign unique timestamp into a transaction once it starts. And kapag nagkaroon ng conflict, it uses that timestamp to correct the execution order. And next one is the strict timestamp ordering. So basically, ito lang yung enhanced version ng basic timestamp, no? Kasi it prevents yung rollback kapag nagkaroon ng conflict. So mag-aantay yung isang transaction, and then once na naayos na yung conflict, it will then execute. Kasi sa basic timestamp, kapag nagkaroon ng conflict, magro-rollback lang siya. And then mag-execute, so magre-restart yung kanyang timestamp. So punta naman tayo sa performance modeling. What is database performance? So database performance refers to how efficient a database processes queries and transactions. A good performance means that faster response times and efficient use of resources. And what is database performance model? A database performance model is used to predict how the database will perform under different conditions. It helps us identify bottlenecks, compare different configurations, and improve the database performance. So, for our performance metrics, we have the query execution time. No, it measures how long a query takes to execute and helps us identify slow or inefficient queries. Throughput or transaction per second measures the number of transactions processed per second and indicates how much work the database can handle. So next one is resource utilization. So it monitors CPU, memory, and disk usage to identify resource limitations or inefficient operations. So next one naman is yung disk input, output, and wait times. So it measures storage activity and waiting time to identify possible data retrieval and storage bottlenecks. So next one is, or lastly, is yung ating concurrency metrics. So concurrency metrics monitors deadlocks and lock wait times, and to identify transactions that are interfering with each other. So here, this example shows the performance metrics that can be compared before and after the optimization. So after the optimization, the query takes less time, the throughput increases, CPU usage decreases, and disk and lock weights are reduced. And this shows how a performance model can help us predict and evaluate the effects of database optimization. And for my references, and that's it. Thank you guys for listening.